Suppose what we learned is that we could shift the function left or right, and that's by adding or subtracting a number to x inside the parentheses. Then we learned that we could shift the graph vertically up or down by adding or subtracting a number outside of the parentheses. And then lastly, we can shrink or stretch the function. Now the stretching or shrinking can be horizontal or it could be vertical. This is based on this. So if I say y is equal to f of x, but I divide x by a number, then depending on the value of x, if x is less than, if x is greater, if c is greater than 1, then we stretch it by a factor of c. If c is less than 1, then we shrink it by a factor of c. Okay? Now vertically it's the same thing, except we have the constant in front of the function. So let's look at a couple of examples. So in example number 5, and I'm just going to show it right out of the book because the book does a pretty good job of showing you the different functions and how they're done, or what they look like graphically. So for time's sake, we'll just read it right out of the book. It says, let c sub 1 be the curve defined by y sub 1, which is equal to f of x, which is equal to x cubed minus 16x. Find the equations for the following non-rigid transformation of c sub 1. While c sub 2 is a vertical stretch of c sub 1 by a factor of 3. Now for a vertical stretch, what we need to do is put the number in front of the function. So really what I would do is I would change that to, I'm going to skip ahead and do part A. What I would do is, to do that, I'm simply going to say y sub 2 is equal to 3 times the function. Well, my original function was x cubed minus 16x. So I just multiply everything by 3. Now, if I graph that, let me show you what the graph looks like. The graph it's stretched vertically. Okay? So the blue function is the blue line is the original function x cubed minus 16x. But the black function is the stretched one. So by multiplying every term by 3, what we do is we kind of take this blue function and we just kind of stretch it out in a vertical direction. Now if I were to make that number less than 1, it would shrink it, flatten it out kind of. Does that make sense? Now let's look at part B. Part B, for example number 5, says that we want to do a horizontal shrink of a factor of 1/2. So to shrink it horizontally, we would compress it. So now let's look at let's look at the algebra first. So what I would do is I would divide by 1/2. Well, when you divide by a fraction, you multiply by the reciprocal, but notice that the 2 is inside the parentheses. So my original function, x cubed, now becomes 2x cubed minus 16 times 2x. Do some fancy math and I get the transformed function as 8x cubed minus 32. Well, what does that do? The black line is the stretched or shrunk line. So the blue line is the original function 16x cubed minus 16x, and what we've done with that is we shrunk it horizontally. We just pinched it by a factor of 1/2. We literally made it half as wide. How do I know this? Well, look at the x-intercepts. On the blue function, the x-intercept is at 4. On the black curve, the x-intercept is at 2. Same business over here. We've got -4 as our original x-intercept and -2. Does that make sense? Now if we shifted this over left or right, the numbers would change a little bit. But I picked some numbers to let you know that we've literally taken this and stretched, or well, it's stretching and shrinking is the same thing, It just depends on the number. But we've just compressed it down a little bit. Now you might ask yourself, well, Mr. Adams, what does all this business mean? What does this have to do with math? Why do I need to learn all this stuff in my pre-calculus class? When am I going to use this in the real world? Wah, 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 I don't want to do math. Well, what happens in the real world, since you're asking, is we have data. We can go out and measure data. And we can measure two things, and we want to see if there's some sort of correlation. And so I go and I measure a bunch of stuff. And as I'm measuring stuff, I notice that that fits a pattern. So when I look at that pattern, I say to myself, that looks like a cubic. In other words, I think automatically y equals x cubed. And if I were to extend this line out, right, the function y equals x cubed normally graphs like this. So now what I need to do, the reason why I care is that I want to make a curve that fits this so I can have an equation to make mathematical predictions based on the data that I've recorded in nature, whatever the case is. So what would I do to make this blue line fit this? Well, I'd certainly have to shift it up, right? So I'd have to shift it up. I'd have to shift it to the right. And I'd have to shrink it a little bit. I'd have to stretch it vertically, right? So I'd have to stretch it vertically. And maybe that would be enough. Wait, how do you spell stretch with a T, right? Yeah. Well, we do one thing at a time. So what I want to do is I want to take this point right here, and I would want to move that point to about right here. So I would go up, I don't know, maybe I'd go up D units. I don't know what the number is, but I would go up D. And now I need to shift it over here. I don't know how many units these are, but I would need to shift it over C units. And then I need to vertically stretch it. So to vertically stretch it, I would need to do some other manipulations. But the vertical stretch would be a scale factor. Now if I want to vertically stretch it, how would I do that? Well, to vertically stretch, I need for it to be greater than 1. So maybe my vert stretch, maybe it's 2. Who knows what the number is? But we'll call the vertical stretch B. So what my goal is basically to create an equation that comes through here like this based on the parent function y equals x cubed. So how do I write that? I would say y equals. Now in parentheses I would say x. Now if we're shifting to the right, I would minus how many units? C units, right? Because that's the horizontal shift and we go in the opposite direction. Then I would want to shift up D units, right? So what would I do? I'd say plus D. And then to vertically shift this.
Okay, would the 9th and 10th graders who need your picture is taken, please go to the gym lobby, including faculty and staff. Thank you.
And then to vertically shift this, I'd have to multiply the whole thing by b. And then what I would do is once I figured out all those numbers, I'd plug it in, expand everything out, simplify it. This would be my equation, and then I could use this equation for my mathematical model. Oh, one thing I forgot to do is this should be cubed, right? Does that make sense? It's a lot easier when you know what you're doing.